Let us move to the third principle called Liskov substitution principle. It is called LSP in short. What does LSP says is that if a program is working all right with a parent class object, it should keep working correctly if the parent class object is substituted by the child class object. In other words, in order to make this happen, the child class should not alter the parent class behavior in such a way that the child class object cannot replace the parent class object. To be more clear on this concept, let us look into a code example. Here in the code, this is a bad example of LSP. We have got two classes. One, the account class. This is a parent class, and a child class called savings account class, which is inheriting the parent account class. The parent class has a method withdraw. The withdraw method checks for the balance against the amount which is supposed to be withdrawn. If it meets the condition, it will process the withdraw amount. If it is not meeting the criteria, it will throw a runtime exception in the else block. This child class is also implementing withdraw method by overriding the parent withdraw method. In a similar fashion, this is also checking amount against balance. If criteria is met, it will process the withdrawal. If it is not, then in the else block, it is logging some message to the console. Now here, if you look into this overridden method, it is violating the LSP principle. How? Because when a subclass object of savings account is used in place of account class object, this overridden method will be called. The calling function will be expecting a runtime exception when the conditions are not met, but it is not throwing that exception here. Instead, it is logging some message. So this is violating the LSP principle, because now the child class object cannot be used in place of the parent class object. What is the right implementation by adhering to the LSP principle? Now let us look into the correct implementation of this code meeting the LSP principle requirements. So here the same account class and then savings account class, extending account class, and the subclass is overriding withdraw method. Here, if condition is met, process the withdrawal. If the condition is not met, throw new runtime exception. So parent class was throwing a runtime exception when the condition was not met. Now child class method is also throwing the runtime exception when that fund requirement condition is not meeting. A code which was calling some method on the parent class object was expecting a runtime exception if condition is not met. Now, if we replace the parent class account class object with the savings account class object, the calling code will still get the runtime exception if condition is not met. This meets the requirement of Liskov substitution principle, where a child class object can substitute for the parent class object.